As you start your study of Algebra 2, let's do a quick review of absolute value and solving absolute value equations. So let's first start with what is absolute value and what does it mean? In math, when we talk about the absolute value of a number, you can think of it as the distance the number is from 0 on a number line. So the absolute value of -3, or the distance that -3 is from 0, equals 3. So remember absolute value, we use those two bars around it. You might have learned the rule, well, when you're taking the absolute value of a number, you just give the positive value. That's because it is distance. We always express distance as a positive number. Sometimes, though, with algebra, we need to work backwards with absolute value. So we're given the distance, and we need to find the number. So look at this example. So it says solve the absolute value of x minus 0 equals 3, or the absolute value of x equals 3. So what this is saying is that it is the difference or the distance between some number x and 0, and that distance is 3. So we're looking for the two numbers that have a distance of 0 from 3, and we know that it has to be 3 and -3. So the absolute value of some number x that equals 3 are the numbers 3 and -3. Let's look at this one. So here we have the absolute value of x minus 2 equals 4. You can think of it as the absolute value of or the distance between some number and 2 equals 4. Now you may be able to picture that, but you can just set up two equations to solve. We know that there's going to be a number in the positive and the negative direction. So we use that logic to set up two equations. So look below, notice I have two equations set up. I have dropped the absolute value bars because these equations that I'm setting up are the definition of absolute value. I have x minus 2 equals positive 4, that's my positive case, and x minus 2 equals -4, that's my negative case, going in the negative direction. So now I just simply do the math. So the two numbers that are 2 away from 4 are 6 and -2. And I am just checking my math on this. And actually, I said that wrong. Not 2 away. They are 4 away from 2. Okay, so solving absolute value equations, we're going to set up both a positive and a negative case and solve both. So the absolute value, or the distance of some number between some number and 5, is 12. But let's just set up our two equations. So we have x minus 5 equals positive 12, and x minus 5 equals -12. Now let's add 5 to both sides. So x equals 17 and x equals -7. So the distance between 17 and 5 is 12, and between -7 and 5 is also 12. All right, let's try this one. So -3x equals positive 30, and -3x equals -30. So x in this case will equal -10, and x will equal positive 10. Now you do want to check these absolute values. So if we plug in -10 into our original absolute value, we get the absolute value of positive 30 equals 30, which is true. And then if we plug in positive 10, we get the absolute value of -30 equals 30, and that's true. Now look at the next one. It's a little more complicated, but it's the same idea. We're going to set up two cases. So it equaling positive 3x plus 5 and then -3x plus 5. So let's solve our equation on the left first. We're going to combine our x's and our numbers. So -8 equals 2x, so x equals -4, possibly. We'll check that in a moment. We're going to distribute that negative and then combine our x's on one side and numbers on the other. So we get 4x equals negative 2, or x equals negative 1/2, possibly. Now, if I plug that in, the negative 4, I get the absolute value of negative 7, which is 7 on the left side. And then if I plug in negative 4 on the right side, I get negative 12 plus 5, which is negative 7. So that is not true, that the absolute value of negative 7 will not equal negative 7. It will equal a positive. So that one actually won't work for me. Oh, now the last one. Let's get started. So the first thing we need to do before we set up our two cases is make sure our absolute value is isolated. So I'm going to divide by that 2 and then set up my two cases, a positive case and a negative case. And then I'm going to solve both of these and check. So x potentially is 6, and add my 8. X is potentially negative 2/3. If you plug both of those in, they both work. So to solve absolute value equations, you're going to isolate the absolute value expression and then set up a positive case and a negative case. Guess what? It's the same way with inequalities. The one switch up is that as you set up your second negative case, you have to switch the inequality, and solve both. Then we're going to talk about these inequalities as an and inequality or an or inequality. So we have 3x minus 15 is less than positive 30, and then 3x minus 15 is greater than or equal to negative 30. So notice when I set up my negative case, I switched my inequalities. You do that just because of the nature of inequalities. Then we'll just go through our solving steps, which we've already talked about. So x is less than or equal to 15. And then I add 15 and then divide by 3. So x is greater than negative 5. Now think about that. Can x be less than or equal to 15 and at the same time greater than or equal to negative 5? Yes. So I'm going to write that as a compound inequality. And we call that an and inequality because our unknown can be both of those criteria at the same time, this and that. When we graph it, you do a simple number line. You're going to mark both of those points, negative 5 and 15, with a solid dot, and then show all the numbers that are in between. Now let's solve our next one. So we have 4x plus 5 is greater than 12, and 4x plus 5 is less than negative 12. So notice I set up the negative and I reverse the inequality sign. So x is greater than 7/4, and x is less than negative 17/4. Now thinking about that, can that happen at the same time? It cannot, because we have values that are becoming greater than 1, a positive value, and less than a negative. So this is what we call an or inequality. X can either be one or the other. When we graph it, we set up a simple number line. I always put things in terms of decimals. So 7/4 is 1 3/4. Negative 17/4 is negative 4 1/4. I do an even scale, and then I mark those two. It's not equal to, so it's going to be an open circle. And then I'm going to show everything that's greater than 1 3/4, so I shade off to the right in the positive direction, and then less than negative 17/4, so I shade off to the negative direction. And that's what an or inequality looks like when it's graphed. Let's try a few more. So on this first one, we need to isolate this inequality. So we're going to add the 15 to both sides. And then we'll set up our two cases. And we're going to switch that inequality. And then we'll solve. So x is less than or equal to 3 and greater than or equal to negative 10. So I think, can that happen at the same time? Yes. So this is an and inequality, and I write it as a compound together. And then as I graph, I'm going to put my 2 marks at 3 and -10 solid and graph everything that's in between, or shade everything that's in between. All right, now we're setting up our next one. So less than -7, and then we're going to solve both the one on the left and the right. So x is less than -5/2 and x is less than. Now realize when you divide by -2, you have to switch that inequality. I look at this and say, can x be less than a negative number and at the same time greater than a positive number? No. So this is an OR inequality. When I graph it, it's on one number line. -5/2 is -2.5 and 9/2 is 4.5. So I put open dots at those points and show my shading off to the positive of 4.5 and to the negative of -2.5. All right, that was a lot, but that's how we do absolute value equations and inequalities.